We're now in section 1.3, and the I can statement for today is I can combine integers. And we've talked over and over again about what integers are, so we should be clear on that. Don't forget that. But when we say the word combine integers, that really covers two things. Some people will call this adding and subtracting. Adding and subtracting integers. We're not going to make a huge differentiation between the two of those things, and you'll see why. We're going to call it combining integers because in the long run that's the way we're going to talk about things and you're going to do things. But as a warm-up, here's what we're going to go through. We're going to go through some money examples, and we talked about using money as examples for integers, like owing money and is a negative and having money as a positive. But we're going to run through and do a couple of examples, and then I think you'll be able to figure these out, and then we'll come back and we'll talk about how we can use the rules that we're going to figure out for combining integers in order to kind of verify these answers. So it says, be prepared to discuss your answers with the class. State your answers as have this many dollars or owe this many dollars. So I'm going to read through these, and I'm going to give you, 10 seconds or so. If you want to pause the video and think about it for a second, that would be fine. So it says, if you had $10 and your grandma gave you $5, how much do you have or how much do you owe? So that one should be pretty easy. If we've got 10 bucks and our grandma gives us $5, we're going to have $15. If you had $7 and you owed your friend Cameron $9, how much would you have or owe? So you've got $7, but you owe your friend Cameron $9. By the time you pay him the $7, you still owe him $2. If you owed Sarah $3 and your mom gave you $8, how much would you have or owe? And we'll assume that you're gonna pay Sarah the money that you owe her. So you owe her $3 and your mom gave you $8. Well, if you pay her those $3, that means you're only going to have, you won't have the $8 anymore, you're going to have $5. And if you owed your parents $50 for some Taylor Swift tickets and then they loaned you another $10 to get a calculator, which you're going to need for this class later, how much would you have or how much would you owe? Well, you owe them already. You owe them $50 already, and then they loaned you the $10 to get the calculator. So that means you're going to owe $60 altogether. Okay, not a good situation there. And then I want you to recall something from elementary school. This is something that you are already familiar with, but I want you to think about this. Which is easier, adding and subtracting fractions or multiplying and dividing fractions, and then why? So think about that for just a second. When you learned how to work with 4 basic operations with fractions, what was easier, multiplying and dividing fractions, or was it adding and subtracting? Well, the easier one is multiplying and dividing. When you're working with fractions, it's easier to multiply and divide. And the reason for that is, in order to add or subtract, you need a common denominator. And getting a common denominator can be kind of a pain in the butt. You don't need that when you're multiplying and dividing, and that's why multiplying and dividing is easier. And that's a lot the same reason why we figured out how to multiply and divide integers before we're learning what we're doing today, which is adding and subtracting integers, or in other words, combining integers. Because multiplying and dividing integers is actually pretty easy. Hopefully you're pretty comfortable with that by now. But adding and subtracting them can be kind of confusing, but if we think about it the right way, hopefully we're going to make this pretty easy for you to do. So we're going to take a look at those problems that we did up above, and we're going to translate those into some integers, and we're going to see if we can figure out some rules where we can just figure out what the answer is without thinking of money examples or anything like that, and get really efficient and really fluent at doing combining integer problems. So again, if we have money, we're going to call that a positive, and if we owe money, we're going to call that a negative. So the integer that would represent the fact that you have $10, that's going to be a 10, and if you want, you can put a positive in front of it, it doesn't matter. And your grandma gave you $5. Well, if she gave us $5, that's going to count as a positive. So what we have here is we have $10, positive 10, and we have another positive 5. So we ended up with positive 15. Now you'll notice that I can erase this sign, and we assume that that one's positive. And if I wanted to, I could erase that sign. And this becomes a problem from elementary school. We already know the answer to this one. 10 plus 5, of course, is 15. Now that matches up with what we have up here. Have 15. That's going to be a positive $15. That's the same thing as we got here. Now let's take a look at this next one. So it says if you had $7, so I'm going to represent that with a positive 7. I'm not going to write the positive because it's right in front and I can assume that it's positive. And you owed your friend Cameron $9. So if we owe $9, we're going to represent that with a negative, okay? And this looks like 7 minus 9. And if you remember what you learned in elementary school, you can't take away a bigger number from a smaller number, but we can if we're talking about integers. So if we have $7 and we paid $9, if we had $7 and we owed $9, by the time we paid them the $7, we're still in the hole, but we're only in the hole $2. So the answer to this one is negative 2. The number 9, is bigger than the number 7, and it happens to be negative, so we're still in the hole $2. And if that seems a little bit confusing, we're going to talk about this more and we're going to do a bunch of examples, but notice that it matches up with our answer right here, that we owe $2. O would be negative, so we've got our 2 right there. Let's take a look at the next one. If you owe Sarah $3, so that's going to be a negative 3, and your mom gave you $8, so we're going to represent that with a positive 8 because that's good. We got money there. Let's see, we've got negative 3 plus 8. We owe $3 and we have $8. Well, let's see, if we took 3 of these dollars to pay that off, to kind of cancel that debt out, what we'd be left with is we'd be left with $5 and it would be positive. So I'm going to leave it like that. And if you owed your parents $50 for the Taylor Swift tickets, that's going to be a negative 50 or a minus 50. Okay, and they loaned you another $10, so you're in the hole another $10. Well, what you owe altogether, you owe 50 and you owe another 10, so altogether you owe $60. So you'll notice that this problem right here, where they're both negative, we actually add the numbers together, so we end up with 60, and then the answer turns out to be negative. Very similar to what happened up here in this first example. This was a positive 10 and a positive 5, and they combined to be a positive 15. These two problems, A and D, are very similar, and B and C are very similar, because what we did here is, you'll notice that the answer is 2. Well, a 7 and 9, they've got something to do with 2. We can actually do a little subtraction problem and find out what the difference is. Same with the 8 and the 3. The question is, how do we figure out what the sign of the answer is? And that's what we're going to talk about today. We're going to figure out what we can do to find what we get when we combine integers. So here are the basic rules. We're going to cover this in kind of 2 steps, but we've got to make sure that something is true before we try and combine these. As long as there is only one sign in front of each number, so you've got to make sure that there's only one sign in front of each number, we're going to use the following rules to combine integers. And this is something that you're going to want to memorize. It's not going to be this long. We're going to kind of summarize this toward the end. If the numbers have the same sign, so we're going to write the word same here, then what we do is we find the sum of the numbers. And sum means that we're going to add, whoops, let me make that look a little bit better. That means we're going to add the numbers. And then we give them the same sign that they both have. So if the numbers have the same sign, so if we're dealing with integers that have the same sign, then we find the sum of the numbers and we give the answer the same sign that they both have. Now, if the numbers have different signs, so write the word different in here, if they have different signs, we find the difference between the numbers, difference. And when we say difference, you might remember that difference means we're going to subtract. So we subtract, and we're going to do this in a particular way. We're going to subtract the smaller number from the larger one. Okay, and then give the answer the sign of the larger one. And when we say larger in this particular case, I have that in parentheses, or sorry, quotation marks, because when we say larger, what we mean is the biggest one in absolute value. Which one's the biggest one if you just covered up the sign and they were both positive? Okay, so absolute value. So here's how we apply these rules. So you'll notice that the first thing's taken care of. We've only got one sign in front of each number, and that is true for each one of these examples. So we're going to go through each one of these examples, and then I'm going to show you on a number line how you can hopefully make sense of this as well. So these have the same sign, so here's what we're going to do. We're going to find the sum of the numbers, and what I'll do a lot of times, and I know you can still see this, is I actually try and cover up the sign. So I'm going to scribble that out and scribble that out. So we're dealing with the number 4 and the number 6. Well, if they have the same sign, we're going to find the sum. So the sum of the two of those is 10. And then we give the answer the same sign that they both have. So I'm going to expose that again. And they're both negative, so we keep that same sign all the way through, so the answer is negative 10. So there's the answer right there. Let's check the next one. There's only one sign, one symbol in front of each one. We've got a negative in front of the 8, we've got a positive in front of the 10, and we're supposed to combine the two of those together. So they have different signs. Well, if they have different signs, we're going to use this rule right here. If they have different signs, then we find the difference between the numbers. And when we find the difference between the numbers, we're going to subtract the smaller one from the bigger one. So again, I'm going to cover these up. Again, I know you can still see them. Okay, in class I use my thumbs to cover them up, or my hands to cover them up on the board, but here's what we're going to do. We find the difference between the two numbers, so what we're going to do is we're going to do 10 minus 8, and we end up with 2. Now the question is, what's the sign of the answer? Well, in order to figure that out, we give the answer the sign of the larger one. So while the sign's still covered up, look at the 8 and the 10. Which one's bigger? The 10 is bigger, and it's positive, so the answer is going to be positive 2. All right, let's take a look at the next one. You'll notice there's no sign in front of the 4, so we assume that that one's positive. And the sign in front of the 12 is negative, so we've got a positive 4 minus a 12. And we want to combine the two of those. So you'll notice that they have different signs, so we're going to be using this second rule right here. If they have different signs, then we're going to find the difference between the numbers. So again, I'm going to cover those up. We're just going to find the difference between the numbers. We do a little subtraction problem. So this is going to be 12 minus 4. We're going to subtract the smaller one from the bigger one, and we end up with an 8. Now the way we figure out what the answer is we figure out of the two numbers, we give the answer the sign of the larger one. So which one's bigger? This one's bigger. The 12 is bigger. It happens to be negative, so the answer is negative. All right. So got the right answer there. And again, we're going to look at these again with a number line and talk about them in terms of money and that sort of thing in just a second. Now, you'll notice that this one's positive. These both have the same sign. If they have the same sign, then we find the sum. So that means we're going to add the numbers together. If you needed to do something like this off to the side, that would be totally okay. And then we give the answer the sign that they both have. It keeps the same sign all the way through. So if these are both positive, then the answer to this is positive. So I'm going to leave it just like this. If you wanted to put the positive sign in front, that would be totally okay. So stop and think about this for just a second. We'll talk money, and then we're going to do a number line example for each one of these. So if you owed $6 and owed somebody else $4, altogether you're going to owe $10. When you combine those debts together, you're going to get minus 10. If you owe somebody $8 and you have $10, by the time you pay them the $8, you're going to have $2 left over, so that's going to be positive. If you have $4 and owe $12, by the time you pay somebody those $4, you're still going to owe them $8, so that's why it works out to be negative. And if you have $2 and you get another $7, altogether you're going to have $9, and again, that's why the answer there is positive. All right. We don't need the sign in front of this, so if I wanted to, I could leave that off there. That would be totally okay, but there are the answers. Now we're going to take a look at this and see why this works the way it does on a number line. So this is the number that we're going to start with. We're going to start with -6. So here's 0, and -6 is right here. So if we started at 0, -6 puts us right here. Okay, so there's a -6. and then we're going to subtract 4. That means we're going to go in the negative direction, so we're going to go to the left another 4 units. So there's 1, 2, 3, 4. So we're going to go all the way to there, and there's the answer. The answer there is -10. Matches up with what we had right there. Let's take a look at this problem right here. We got a 2. Let's see on the number line how we come up with a 2. So we're going to start with -8. So that means we're going to go to -8 on the number line. So we end up right there with that number. And then we're going to add 10 to that. Well, if we add 10, we're going in the positive direction. Remember, the positives go off here to the right. So we're going to add 10. So if we add 10, if we go to the right 10 units, there's 8 of them, and there's another 2. That gets us to 10. Okay, so that means where we would end up is we would land on +2. Same answer as we got there. Let's do the 4 and the 12. So the 4 is positive, so that means we're going to jump over here to +4 because that's representing in a positive direction. Then we're going to subtract 12, so that means we're going to go back 12 units. So going back 4 is going to get us back to 0, and then we've got still another 8 to go right here. So if you were to count up how far it is from this 4 to the -8, it's 12 units, but we went in the negative direction. So the answer to that one is -8. And then this one, hopefully this is the easiest one. We start out with a 2, so we're going to hop over here to 2 in the positive direction because there's no sign in front of it. And then we're going to go another 7 in that direction. So we're going to add another 7. We're going to go 7 more in the positive direction. And we end up right here. And again, you can count these. There's 1, 2, and then we're going to go another 7. 1, 2, 3, 4, 5, 6, 7. So we end up at 9, and 9 is the answer. So this is kind of a graphical way of figuring out what the answer is. And number lines are fine, but what we want to be really good at is we want to be really fluent at using these rules and getting the answers very quickly. And I'll be honest with you, this is going to take some practice, and we're going to do a lot of that. Okay, so hopefully you can kind of get the idea there. So we're going to go ahead and flip over to the other side, and you're going to notice something different about these particular problems right here. On some of these problems, there is more than one sign in front of each one of the numbers, and that does not work for us. We want to make sure that there is only one sign in front, and we use the rules of multiplication in order to put one sign in front of each one of those. So we're going to rewrite every one of these. So I'm going to underline this right here. These problems must be rewritten to show your work correctly and to make sure that you can apply the rules the right way. And this is the way you're going to be doing these problems from now until you're done taking math. You're going to use this concept in every math class that you're in, so I advise you to practice this way, think about the problems this way, and you'll be much better off in the long run. So you'll notice that this only has one sign in front of it. We're totally okay with that, so that's a -10. This one has two signs in front of it. This has a negative and a positive. So we've got a positive and a negative with nothing in between. Remember the rules for implied multiplication? That's what this is. This is like having a positive times a negative. A positive times a negative is a negative, and we've got a 12. Now we can apply those rules. These happen to have the same sign, so we're going to find the sum of the numbers. The sum of those numbers is 22, and we keep the same sign all the way through, so the answer is negative. Now what some people will do is they'll say, hey, when you were doing this before, you said a negative and a negative make a positive. That's true when we're multiplying or dividing. That's not true when we're combining these. This is like owing $10 and owing somebody else $12. So altogether you owe $22. So make sure you're careful with that. That's why this can be confusing when we start mixing these rules together. So let's take a look at this one. You'll notice this one has two signs in front of it, but this one doesn't. So we're okay with the -5. Positive times a positive is a positive. So we have a 10 right there. You'll notice that this one is written smaller and up here just a little bit. Sometimes that happens. That's called superscript. It's the same as just having a regular old plus sign in front there, but we've got a positive times a positive equals a positive. Now we can use our rules because we've got one sign in front of each number. This one's negative, this one's positive. So again, I'm going to cover these up, just pretend. Okay, we need to find the difference between the two of those. The difference between 5 and 10 is 5. We do a little subtraction problem. And then to figure out the sign of the answer, we figure out which one's bigger in absolute values. So the biggest one is the 10. The 10 is positive, so the answer is positive. So again, I could leave that positive right there and circle it and say I'm good. Or if I wanted to, I could just erase that and say, okay, the answer is 5. And everybody understands that that means positive 5. So let's take a look at this one. We've got an 8. That's understood to be positive. If you want to, you can write that down. Then I've got two signs right next to each other, so this is a negative times a positive. That's going to be a negative. And we've got a 15. So this is a positive 8 combined with a negative 15. You'll notice that they have different signs again, so we're going to want to find the difference. So again, I'm going to cover up the signs. We're going to find the difference. That means we're going to subtract those if you need to. We could do a little subtraction problem off to the bottom. Okay, so this is going to be 7. Okay. And then to figure out the sign of the answer, the bigger one is 15. Let's see what that one is again. That one's negative, so the answer on this one's negative 7. Which hopefully makes sense, because what we had here is this is like having $8 and owing $15. Once you pay them the $8, you're going to still owe $7. And again, once you've got that one sign in front of each one of these, you could do a number line example for each. Okay, let's take a look at this last one. So this is going to be a 3. Again, we assume that to be positive. I'm not going to write it on this particular one. And then I've got two negatives next to each other. Again, this is implied multiplication. Negative times a negative is positive. So this is going to be 3 plus 7. Now you'll notice how cool this is, because this is a problem that we for sure know the answer to. We've done this problem in elementary school. This is a piece of cake, but let's apply the rules. These are both the same signs, so let's find the sum of the numbers. That means we'd add them together. We end up with a 10, and we keep the same sign all the way through. So if these are both positive, then the answer's got to be positive, and I can circle that. But again, I don't have to write the sign in front of that if it's positive, so there are the answers. Now, what I'd like you to do is I'd like you to try these on your own. So if you want to pause this and then run through and do these, that would be great. I'm going to go through and I'm going to change these. I'm going to rewrite each one of these. So I'm definitely going to rewrite. So here's what I'm going to do. If you want to work ahead, pause this. If you want to follow along, just keep watching. So I'm going to rewrite each one of these. So notice I've got one sign in front of here. That's a negative 16. Negative times a positive is negative, so I'm going to have negative 16 minus 4. Let's take a look at the next one. This has a set of parentheses, but there's only one sign in front of it, so I can go ahead and write negative 11 and then plus 6. This is a 9. Negative times a negative, we've got those two signs in front of each other, so we want to change those. Negative times a negative is a positive, so that's going to be 9 plus 15. And then on this one, we've got a 16, that's assumed to be positive. And then I've got a positive times a negative, that's going to be negative. And then we've got 8. Now, you'll notice that these problems look much better than they did originally. It just looks a little confusing with all those symbols floating around. But now we can apply those ideas that we talked about. Same signs, we're going to find the sum of the numbers. So 16 and 4 make 20. We're going to add those up. Keep the same sign all the way through, so that's going to be negative 20. Different signs, so we're going to find the difference between 6 and 11. We'd subtract those, so we'd end up with a 5. And then to figure out what the sign of the answer is, we look at these two and we figure out which one's bigger in absolute value. We ignore the signs and we say, okay, 11's bigger, it's negative, so the answer is going to be negative. These are both positive, so same sign, find the sum. That means we're going to add the numbers together. So if we add the numbers together, we end up with 24. And they're both positive, so the answer on this one's going to be positive, so I'm just going to circle that one. And this one is positive 16 minus 8. They're different signs, so we're going to find the difference. The difference between the two of them, 16 minus 8 is 8, and the bigger one is 16, and like we said before, it's positive, so the answer on this one is positive. Okay, and again, if you don't want to write the sign there or there, that's totally okay. But you'll notice that this problem, again, like the one up above, it's an elementary school problem. Same with this one. We know those are the right answers, but it's cool that our new rules for combining integers applies here. So we can summarize these rules for combining integers in a few short phrases. There are actually 3 steps. The first one's pretty easy, and then the other 2 are the actual rules for combining these. So first rule is make sure that there is only one sign in front of each numbers, and if you need to, you're going to use the rules for multiplication in order to figure out what that sign is. Okay, so multiplication rules there. Okay, once we have one sign in front of each number, we're going to make those rules on the front side really short. Same signs, find the sum, whoops, make that look better, find the sum, same sign for the answer. So if they're both positive, we're going to keep the same sign all the way through. The answer is going to be positive. If they're both negative, we're going to keep that negative. They're going to have the same sign all the way through. So this is called an alliteration. You'll notice how many S's there are. Same sign, find the sum, keep the same sign. And if they have different signs, so we're going to write the word different here. If they have different signs, then we find the difference. Again, another short alliteration here. They both start with D. We're going to find the difference, and then I'm going to say the larger or the bigger sign for answers. And again, when we say larger in quotation marks, what we mean is the biggest one in absolute value. So if you ignored the sign, which one's the biggest, which one's furthest from 0? Okay, now I'm going to put a star by this. I'd like you to put a star by it also, even though there are already some asterisks there. You need to memorize those rules, and you need to be really fluent with their use. And when we say fluent, what that means is you can use them without making mistakes. So this really needs to be something that you get to be 100% at, 100% accurate, and not have any problems with. Okay, so you're good to start the first assignment in section 1.3, 1.3a. Go ahead and get started on that, and if you've got questions, let me know.